Hi there, welcome back to the new video, and in this video I will show you the decision tree algorithm for regression. So this data science or the machine learning algorithm, which is decision tree, is helpful in doing either the classification task or the regression task. And in today's video we will going to look at the regression task for predicting the prices. So for example, one of the very basic example that I have used to explain the decision tree, well, by the name itself, you can understand that it is related to a tree. And a tree has like a structure which has different branches have leaves, and so on and so forth. And basically that's what the structure which it follows here itself. So for example, this is the starting point of the tree where I have written for a machine learning algorithm or for a problem which is related to the predicting the prices of a house, and a very simple variable that we have taken is whether the house has more than 2 rooms or not. So one of the major factor in predicting or in deciding in real life for a house price is how many rooms it has, whether it has 1 room, 2 room, 3 rooms, and accordingly the prices increase. And same if you see in a form of a tree which it has 2 branches, the branch 1 and branch 2, and with the help of these 2 branches we are figuring out what would be the price. And these branches are conditional branches, as you can see. First is saying no, so the condition is no, and another condition is yes. So it has more than 2 rooms? No, it does not have more than 2 rooms. So the price is $10,000. So either it can be a 1 BHK or the 1 bedroom hall kitchen flat, or in this case the room is more than 2, that means it will be a 3 BHK or a 4 BHK flat. So in that case you can decide with this particular variable that if you are going up to the 2 BHK or the 2 room house, you will get a price of $10,000. If it is more than 2 rooms, then the price will be $15,000. Now the 2 can be more than 2, right? It can be 3, it can be 4, it can be 5. So as you can see, this is just a basic example, but it can be further improved, right? And deciding what node you want to start and what are all the different parameters you want to include. So right now we have just include 2 rooms right over here. But what if after understanding the price, let's say we want another, or there is another variable that we want to consider, like whether the house is properly furnished or not. So if the house is furnished, what would be the price? If the house is not furnished, what would be the price? Similarly, you can go ahead and have more branches like this. I'm just asking you to assume this thing, that after understanding the furnishing, let's say you want to understand how the locality is, whether it has good school or not. So nearby, let's say within the vicinity of 10 kilometers, so how many schools that it has for children's, and what is the teacher pupil ratio. So that's one of the variable which is also present in our data set, which I will show you in a minute, that what is the pupil teacher ratio. That means for each teacher how many students are going. So if let's say one for 20 student there is a one teacher, then you have this 1 ratio. Or if it is like for 50 students you have 1 teacher, then the ratio is going worse. So you would really like to understand what sort of child education you want, what sort of locality you want, what is a crime rate in that locality. So all those really plays a major factor in deciding what would be the price, and price would be the lowest one after you have gone through all these different permutation combinations. So this is just a basic, but we will see within the Python without much going into a lot of theory, because that I will cover it when I will explain you how we are going to do it. So let's go ahead and see this decision tree. So for this decision tree, first of all, we need to import the machine learning library. And as you could see, I am using a different interface than the normal one. It's like black and it is more impactful, give me the less strain on the eyes. And if you don't like it, let me know in the comments, but I find it like more easy. I can see the cursor, but probably you would not be able to see it because it is blinking in a black font. I was thinking of changing it to some sort of a white so that it is properly visible, but I'll do it probably later. So let's go ahead and write import pandas as pd to import the data file, and then from sklearn.tree import decision tree regressor. You have two classes. One is decision tree classifier, as you can see, and one is decision tree regressor. So classifier and regressor are two basically different algorithm. So classification is basically for either the binary or multi-class classification, and decision tree is basically to do the prediction of something like prices in this case, but not the classification task. So we'll go ahead and use the decision tree classifier. Looks like the spelling is wrong, so what I'll do is I'll just check again. Decision tree regressor. Okay, hold on. Decision tree regressor. So even I'm using it first time, so I was getting confused that what it was highlighting is not actually the one which was getting selected. All right, so once we have this, let's execute it, and it shows you some warning. For now you just exclude or just ignore, and I will just hide this view toggle header, and if I want to just remove this as well, I will just say toggle toolbar, so there is more space for me. All right, so now what I have is basically house prices. I can say house underscore prices or simply house, just to get all the variables of the houses. And the file which I have is in the same location where this particular Python file is. So what I'm writing is the pd.read_csv method, and boston.csv is the file name. You can find the instruction in the description to get this file. So once I execute this, you will see that file or the data which is present in this has come over here, and by default I have gone with the default parameters, which means it has gone its header. I don't want to skip the rows, and default delimiter is basically comma because it's a CSV file. But in your case, if it is a different parameters you want to set and you want to see the parameter, you can press shift tab and it will show you all these different parameters. Along with that, you have the description available which you can see, and go ahead and see which makes sense for your data import statement. So first of all, it's a practice for any data scientist to examine the data. So house.head, if you see, and here is a data set, and for some reasons I find it like, maybe it's a change, but I find it's pretty amazing that using this black background or the black theme, because things are very clear to me and not giving a lot of strain to my eyes as well. So what it has, as you can see, is the crime rate and some of the important variables which I am aware of. This is nitrogen oxide, sort of a pollution level, then the number of rooms, average number of rooms, the age of the property, some tax information, the pupil teacher ratio which I was talking to you, and lower status people over here, and B looks like the information about the African American population in that area. So all of these variables are here, and finally MEDV is nothing but the median price of the houses based on all these different factors. So to start with the algorithm, what we need is basically the dependent variable, which is y, and our dependent variable is price because it is dependent on all of these variables. All of these variables basically decide the price of this. So what I'll do is I will simply say house.medv. All right, and then I want x or independent variable. Independent variables are these because it can have any value, and based on whatever value it has, we need to figure it out the dependent variable, which is price. So we will select some variables like crime, NOx, room, age, people teacher ratio, or maybe, and finally maybe the LSTAT. So what we can do is we can call them features, and features equals to, we can save them in a array, which we can change it later, which makes our life easy. If let's say we want to add another variable after running the algorithm first time, just to understand what is the impact of adding another variable, we can easily come here and do it. People teacher ratio LSTAT, L. All right, if we execute this, and now if I say X, and over here I say house, and within that I pass the features, and now if I say x.head to see a couple of observations, so here are my observations which I selected. So this way, if I let's say tomorrow come and say I want the African American population, I will just go ahead and execute, and I have the African American population as well. So this is very easy. So let's go ahead and keep it as part of it, because we are just experimenting with it. So once we have this description, there are a lot of techniques. If you have seen my previous videos, I've talked about the visualization, I've talked about describing the data. So let's go ahead and describe the data. X.describe. If I execute, first of all, we'll see that the count of the values, very important to understand the missing values. And as you can see, 506 is basically the overall count, but in some of the cases like age or crime, and even the lower status, the population, the contribution of lower state population in that locality has some missing values. So one of the very simplest thing what we can do is simply go ahead and drop it. However, there are various methods by which you can impute the missing values, which is another very important topic, so that you are not reducing the values because of scenarios like if you have, let's say, only 100 data points, and out of 100, if there is like 60 or 70 data points, or maybe like 40 data points, if not that, for let's say 30 or 40 data points are missing, then your data, if you are just removing those rows, it will be really difficult for you to prepare a model. So in that case, you need to impute the values. That's a different topic, but for now, x.drop NA is something which I will go ahead and say in place equals to true. If I don't say in place equals to true, the effect will not be applied to the x. But there are a couple of other parameters, like for example, x equals to 0, that means on the rows, yes, I want to remove the rows. But if I say x equals to 1, that it will remove the 1. How equals to any, however, I can specify how I want to remove it. I can specify threshold, subset, and finally the in place. So in place equals to true is what I have said in my case. And if I go ahead and execute it, and now I see x.describe, the describe method, yeah. So DESCRIBE, all right, it was a small x. So now everything is at 446. So wherever it could find the NA, it has removed it. So now after that, what we need to do is, right now we are just creating a very simple model to understand the decision tree classification algorithm and how to implement it. So we'll go ahead and use both x and y, but there are other things that can be done, like dividing them into the train and test data set, which I will show you later. So what do I have is basically the decision tree algorithm. If you remember, we imported it earlier. So what I need is simply a house model equals to decision tree regressor. Okay, and what I'm saying is random state equals to, let's say, 1. So what it means is basically that if you also do the random state equals to 1, you will get the similar results like me. So if I go ahead and execute this, and so this model is something what we have initialized. Now we have to fit the model. So this is called initialization of the model, this particular line, and this line is fitting the variable into the model using the fit method, and we need to pass the x and y variable. X is independent and y is x is independent, y is dependent. So let's go ahead and execute this. Throws an error. Number of label 506 does not match the sample 446. The reason is we have removed the NAs from the x-axis, but not from the y. So the better way of doing it is simply coming over here saying house dot drop NA in place equals to true. Sorry, drop NA in place. Okay, it was a mistake. If I run this again, run this again, run this again, run this again, and run this again, you see that there is a further drop in the data set or in values of a data set, because in the entire data set, if there are other variables where there will be missing values and it has removed from everywhere, and that's why you see why I was saying that drop NA sometimes is not a very good idea, and there are other techniques to remove it. So for now, this statement does not have any significance, so we will not run that, and I will just run the model again. And if you see, the model has run fine, and it has given you the decision tree regression model with the information about what are all the parameters that it is using, right? So these are all the default parameters, and that means if you understand the features, you can change it as per your needs. For example, criterion like a mean squared error, max features, max depth, max leaf node. We will see some of these parameters how we can change it once we understand the basics of it. So once we have this, the next step is to predict it. So for that, we simply have to say that house model dot predict, and we need to, let's say we just want the first 5 variable to be predicted. So x dot head, and these are the predicted values: 24, 21.6, 34.7, 33.4, 28.7. and if we see the values, the first 5 rows, which is house dot head, and if you see the value is 24, 21.6, 34.7, 33.4 and 28.7. that means this is like almost, not only almost, it is 100% correct, that based on what variable we selected, we have got the output absolutely perfect. But this is very incorrect, or this is wrong, and the reason being is that this is a case of overfitting. So overfitting is a case where when we are trying to fit the data on the or trying to fit the model on the entire data and then predict it also from the same data, then it does not really learn about how the real life values or how the unseen data would have given the results. So in this case, we are not exposing our model to the unseen data, and model is learning really well, or maybe point by point with the data set or the column that we have provided. And this case is called the overfitting, because in many cases the model will not work in the real life situation. So we will see this a difference in the next video, which I will show you, where I will going to split the data set within the train and test, and then give you the idea about what sort of values we were getting it over here is different in case of an unseen data, and I will show you the way by which you can even get the error rates as well. Right now we are just getting the predicting out the output in the prediction values, but what if you want to just convey the result to your management that error rate is 70%, 80%, because that's what they understand, but not the value like this. So in the next video I will show you how you can do that, and then take your learning to a next level. So stay tuned for that, and I will meet you in the next video.